Today on Creativity Hero channel, I'm going to make an interactive LED coffee table. This unique coffee table can create beautiful atmosphere and will be a real focal point in my living room. I wanted to make a simple design with some interesting features that will take my room to a whole new level. It is controlled via a custom-made Android application, so I can easily change the reactive color or the background color, and I can even adjust the brightness. The table is made out of MDF for the box, a pine for the legs, a glass top, and its inner part consists of an Arduino board, a Bluetooth module, some LEDs, proximity sensors, and a bunch of wires. This is a very challenging project, but with hard work and patience, anyone can build it. Here I'll show you the entire process of building, wiring, and connecting all the pieces together. Now let's start with the build. First, I'm cutting all the pieces to size on my table saw. I'm going to make a box out of MDF. I'm using 8mm thick MDF for the sides and 8mm thick MDF for the bottom. Most of the pieces I cut using my table saw fence, but for the larger pieces I clamped down a thin scrap wood as a guide because the fence is pretty wide and couldn't be secured to my workbench. Inside the box I'll create a grid out of MDF, so I need to cut 12 pieces 4 cm wide. For the legs and the frame below the box, I used a large pine board. You can notice that it is warped, but I don't have a planer, which means I need to make a lot of cuts and adjustments on the blade and the fence in order to flatten all the pieces. It took me some time until I finished, but finally I got nice and smooth strips, all with the same width. To cut all the pieces to the right length, I used the crosscut sled. For making repeated cuts, I mounted a stop block. Some of the pieces were much longer and I needed to make another stop block. I set the fence and clamped a scrap of plywood on it, which will actually serve as a stop block for the longer pieces. For the grid that I previously mentioned, I should make dados onto each MDF piece so that they can easily lock together and make a perfectly squared grid. So I marked all the points for the dados, wrapped the pieces together with a masking tape, set my blade on the appropriate height and made all the cuts. They were very easy and fun to make. All the dimensions for this table can be found in the video description. There I'll also put links to all the tools and the materials needed for this project. Once I'm done with all the cuts, I can move on to sanding. I started with 80 grit sandpaper and then continued with 120 grit until everything was nice and smooth. First I assembled the box. I applied a nice amount of wood glue and joined the pieces together with corner clamps and a bend clamp. To make stronger connection between the sides of this frame, I added a small piece of wood in each corner and secured them well. After that, I can secure the bottom of the table with the wood glue and a lot of screws to make sure it is firmly attached. I pre-drilled holes and then inserted countersunk screws. In order to avoid any gaps, I'm applying a wood filler on the joining parts of the table. While the wood filler was drying, I made 2 openings on the bottom of the table, one for the high voltage cable and other for the switch. Using a rasp, I made the opening for the switch a perfect fit. When I placed the smaller MDF board into this box, I noticed that it was warped in the middle due to its length, so I added 2 more small wooden pieces into the box for better support. Then I measured the depth of the box and also realized that I should add extra 8mm height onto those small wooden pieces so that when I finally placed the glass on the top, it would be flush with the sides. Fortunately, I had 8mm thick MDF, which is perfect for this purpose. I cut 6 small pieces of it and glued them on the top of the pieces that I previously attached. I fine sanded the MDF to remove the extra wood filler and prepare it for painting. Then I wiped the dust off of the surface with a wet rag. I don't have to paint the entire inner part of the table, so I applied a masking tape on the sides to get straight, clean paint lines. After that, I applied an oil-based primer using a ruler for large surfaces and a brush for the areas that are hard to reach. I left it to dry overnight and sanded the surface with my orbital sander using 120 grit sandpaper. Now it is time to apply paint. I chose an oil-based white paint and carefully applied it on the surface, making sure I cover every part of the table. While it was drying, I moved on to the legs and the frame below the table. I'll join them together with pocket hole screws. The pocket hole jig that I have is very useful and easily adjustable tool for making pocket holes. I wasn't able to make 2 pocket holes on each side due to the width of the strips, but later I can mount corner brackets if needed. Before attaching the screws, I am applying a wood glue for stronger connection. Then I am driving the screws in. In order to make the pocket holes invisible, I inserted the screws on the top of the frame. It was a bit complex step because everything has to be square, but I succeeded with a little effort and focus on my work. Again, I applied a wood filler into the gaps and left it to dry. Then sanded the excess to prepare it for staining. When it comes to the stain, I applied a rosewood stain to get a nice contrast between the top and the legs. I did the same in my previous project and it turned out wonderful. All the pieces that will be used for the grid inside the table I painted white as well. What's left to do is to join the 2 parts of the table together. I clamped the top with the bottom, pre-drilled holes with a countersink drill bit, and then used a lot of screws to secure them together. Okay, now I can move on to the electronics part. The electronic parts that I'm using are addressable LEDs, infrared proximity sensors, an Arduino Mega Board, a Bluetooth module, 5 volts power supply, and a bunch of wires. So first I'm using this template to drill 3 holes into each square, and onto each square I'll insert an LED and a proximity sensor and connect them with some wires. I'll attach everything onto this MDF board. It will be divided into 45 squares. Then I cut 45 LEDs into individual pieces from this strip. I need to cut 5 cm long pieces of red and black wire and strip off around 5 mm of the insulation on their ends. I'll use 1 pair of those for each LED and another pair for each proximity sensor. I'm doing the same with this green wire, but here I'm cutting longer pieces and also stripping off their ends. Then I'm soldering the wires onto the LEDs. The black and the red I'm soldering on the ground and the 5 volts pad, and the green one in the middle or in the data in pad. After that I can move on to the proximity sensors. I separated the infrared transmitter and the receiver and made a larger distance between them. In a normal position, the sensor won't be able to detect a glass on top of the table because the glass won't reflect the infrared light. In this way, I can position the transmitter and the receiver at an angle so that the light can be reflected to the receiver on the other side. So I am removing the transmitter and soldering it back on the sensor, but this time with 4 cm long wires. I used single core wires from an Ethernet cable because they can be easily bent and stay in that position. On the other side of the sensor, I need to solder the black and the red wire to the ground and 5 volts pin and the longer gray wire to the output pin that will connect the sensor to the Arduino board. These are pin headers that I need to solder onto the longer wire ends so they can be easily inserted into the Arduino board. To insulate them, I am using a shrink tube and a lighter. I repeated this step 45 times. Here you can see all the LEDs and the sensors ready to be attached onto the MDF board. The LEDs are the first to be attached onto the board. I inserted them into the holes that I previously drilled, peeled off the tape cover on the back and stuck them onto the board. Then I connected them by soldering the green wire in the middle of each LED or the data out pad of the previous LED to the data in pad of the next LED. Once I'm done with the LEDs, I'll do the same with the proximity sensors. This time I'll hot glue them next to the LEDs. Here I need to pay attention to the length of the gray wires. All of them will be inserted into the Arduino board, which will be positioned in the middle of the back side of the board. So the cables that are further from the Arduino board are longer, and as they are coming closer to it, they become shorter. You can find the exact dimensions that I used on the website article. The infrared transmitter and the receiver need to be placed facing up, so I'm making some adjustments here. Now I'll turn the MDF board to the back and connect all the wires. I'll start with hot gluing copper wires along with the length of the board. They will be used as power lines for the LEDs and the proximity sensors. On the first line, I'll solder all red wires, and on the other line, all black wires. Before soldering, I need to remove the insulation off of the copper wires with the sandpaper, otherwise I won't be able to solder them. It took me a long time until I finished soldering all the wires. At the end, I connected all the positive and all the negative lines. Also, on these lines, I soldered 2 more wires, which I'll later connect to the power supply. I added 330 ohms resistor between the first LED and the Arduino to reduce the noise on that line. All the wires are ready, so I carefully insert them into the Arduino board in order. Here I am also inserting the Bluetooth module. This is the complete circuit schematic where you can see how I connected everything together. For more details on how to use the Arduino in combination with these addressable LEDs and the Bluetooth device, you can check Dan Nedelkovsky YouTube channel and his website howtomechatronics.com. He made a tutorial on how everything works, including the source code of the program and the custom-built Android application. I'll put a link to his video and article in the description below. Dan makes awesome videos in the area of mechatronics, providing complete explanation, circuit schematics, and source codes. Before mounting the power supply, I made a continuity test on the circuit using a multimeter. The multimeter didn't beep, which meant my connections were all good. Now that I am done with it, I can mount the 5 volts power supply on the bottom of the table. It needs to be raised up just a little to get better airflow. Therefore, I glued 2 pieces of MDF and placed the power supply above them. Then I pulled the switch and the main power cord into the appropriate holes and connected them to the power supply. 4 meters of the cord is enough for my space, so I cut it to size and wired a plug on its end. After that, I brought the MDF panel and connected the last 2 wires into the power supply. At this point, we're ready to program the Arduino. The code is fairly simple, it just reads the proximity sensor, and if an object is detected, it lights up the particular LED. For the color and brightness control, we use the custom-built Android application. The data coming from the smartphone is received via the Arduino Bluetooth module. As I mentioned earlier, you can find detailed explanation on how this code works on Dan's article. Once I uploaded the code, I placed the panel inside the table. I noticed here that the power indication LED of the proximity sensors would interfere with the main LED light, so I covered them with an electrical tape. Making the grid is very easy. I just need to lock all the parts together, and as you can see, they fit snugly. Finally, I can put the matte glass on the top of the table, turn the switch on, and check if everything works properly. One of the LEDs doesn't turn on when I place a glass on top of it, so I removed the glass and adjusted the transmitter. It needs to be positioned at the right angle to be able to reflect the light to the receiver. Now I can say that I'm finally done with this project. This interactive coffee table turned out perfect. I like every part of it, including the design, the color change, and the brightness adjustment. It gives another dimension to my living room. Thanks for watching. I hope you enjoyed this amazing DIY project. If you like this video, give me a thumbs up, leave a comment down below, and subscribe to my channel.